Okay. There seems to be something, right? But no, I don't know. So we have the tip of the week, and because I get a lot of questions, what is the environment variables in Bash? And it's also important for the assignment. So I give you a 5-minute introduction into environment variables in Bash. And so maybe one of the core motivations is that imagine you have a script, and the script has a lot of parameters that you want to that you might want to change. And so one option would be, of course, to add command line arguments for all these parameters and let the user pass them in by command line arguments. The problem is then your statements become kind of, when you call up that function, it becomes very, very long every time you want to call that function. And so often it's quite useful to change the behavior of often it's quite useful to use another type of where you can change the behavior of a program. And that's called the environment variables. So essentially, the core idea is that these are variables, Bash variables, that are available not just in that one script, but they're available in the entire Bash session. Right? So these are variables that are accessible for every script that is run in that Bash session. And so I give you an example, or I explain to you first how you set these in variable. Use the export statement. So you say export my variable, for instance, equals hello. Then I press return, and so now I've created a new variable, a new Bash variable with the name my variable that has the value hello. And any script that I run from now on can query the value of that variable. So for instance, what I can do is I can just write echo my variable, right? And I get the word hello out. But what I could also do is I could write a new script, and I could write this. And so by itself, this doesn't really make sense because my variable, I've never defined my variable in that script. But because I have an environmental variable with that name, I can now run the script and still get the value hello out. Okay? So these are environment variables. And they're used in Unix systems all over the place. So one way they're used is, okay. That's maybe not so, maybe I show you instead my bash rc file. So the bash rc file is a file that is being, this is called every time you launch a new bash session. And here you can see my, my version of that. So you see there's a lot of command, and most of them are, it's not so interesting. But let's see. Let's see which kind of exports I do. Oh, that's a bit messy. I'm not sure if that is such a good example. But so here, this line here, export PS1, here actually specify how the command should look like. If I, this string here in front of the command shell, you can customize this. And the way you customize this is by setting the environment variable called PS1. And so, I mean, I don't even know what all this means, but essentially what you end up is with your username of that you currently logged in, with an @ and then the computer name, and then the current directory. And so I customized this because I wanted to have okay. So I wanted to have, if I'm in a Git directory, for me, it shows automatically that my command prompt here shows automatically that I'm in a Git directory, and it also shows in which branch I'm in, right? So these kind of things you can do by changing the environment variables. Does it make sense? Yeah?
Script depends on the environment variable, and it isn't set. What's the best way for all the users to set it?
Yes. So okay, the question is, what if your script depends on an environment variable, but it's not set? So let's now, in this command shell here, I've set the export the my variable up here, right? And then I can run test.sh and I get well, here it was actually 5 out. But now, if I open a new shell and I run myscript.sh, right? So here I haven't set it yet, and as a result, I just get an empty string. And so what you could do is you could just test if you could have an if statement checking if my variable is empty, and in that case you kind of prompt an error message, or you maybe set it to a default value. And if it's set, or if it's a non-empty string, then you use that instead. So that's a behavior that is often used in bash scripts. Yeah.
You can also write $curly brace environment variable, and then I think it is plus, and then a string, and then if the name is not defined, then he will use that string.
Yeah.
It's one of those characters,
yeah.
Plus or colon, minus or whatever. I'm not sure exactly which can be looked up.
Yeah, thanks. So I hope that clarified the environment variables. Now let's go back to to Python. We've just learned how to handle lists and how to loop over lists. And just to finish that off, one useful command that is often used is if you want to loop over a range of numbers. So often, you want to range from 1 to 10 or from 1 to 100. So there's this command here, range. It's a Python command, range, and you pass it a number, and what that will, well, I have to be careful here, but what it used to do in Python 2 is that the range command actually generated a list starting from 0, 1 to all the way up to the number that you specified, -1 actually. So in this case, you would get a list with 0, 1, and 2. And then, of course, if you do for I in range 3, print I, right, what you get is every single number in that length. So that's often useful if you want to index over a long list and you want to generate these indices. Right, so the reason why I'm careful here with saying that range generates a list is because that's actually not true anymore in Python 3. So this works just fine. But now let's just execute this. And we can ask for its type. Oh yeah, that's not very. Right, but you can see if I run this, right, you instead of getting a list, you actually get this kind of function, and this is an iterator, which I don't explain right now. But the point is that you can actually convert this into tuple. If I do an explicit conversion, you get a tuple, or you could also write list here, and then you would actually get the list that you're working on. So what you could do is for I in tuple range 3, print I. Yeah. Functions. of course, functions are really important. They allow you to encapsulate commands that you want to call over and over again. And you can then call all these instructions in a single line of code. The way you do this in Python is with a def. There's a special keyword called def for defining a new function. Then you have the function name, and then you add the parameters that this function should take. And then the colon, like always. And then all the commands that should be part of that function are indented again. Right? So it's always the same. For for loops, while loops, if statements, and functions, we always have to indent. And so here we add the commands that the function should execute. And inside that function definition, we can make use of the variables that the user passes in. So what this function here does, the split function, right? It takes a string and it takes a character, and the idea is that it should split the character, the string at that character. So what I do is I use the .find command, so I call string.find character, and that gives me the index where that character appears. And so if that character doesn't appear at all, then this position will be 0, and otherwise it will be positive. So if an if statement, if it's positive, then I do return the value, and my value will be, so see, this is interesting. So here I return a tuple. I left out the curly brackets, but you can see it here from the comma. So my tuple has 2 items, one here and the second item here. And the value of that first item is the string, and here I use this slicing notation. I slice the string starting from the very beginning up to the position +1. So I get the left side of that splitted string. And then the second component of my tuple is the string again, now starting at the position +1, colon, all the way up to the end. So that's exactly what I wanted to do, is split the string into these 2 components. And of course, if the character never shows up in my string, then I just return the full string followed by an empty string, again as a tuple. So when you run this, when I execute this code here, nothing happens. So, like functions definitions, they're like, I mean, if you're a chef, they're like reading the recipe on how something should be cooked. So nothing happens here yet. It's only when we call the functions that the commands are being executed. So how does that work? So what we do is we create a new message, a new string, hi son, and then we call our split function on that message, and we say that we want to split the string on the character I. And then when we print the results, then, not surprisingly, we get a tuple, right? Here the normal brackets are explicitly stated in the print statement. And then the tuple has 2 components. The first one contains all the characters up to my I, and then the second part contains the rest of the string. Yeah?
I have a question. In the position equals string.find char, if the character is the first, wouldn't it return 0? And this would should not be correct. Shouldn't it be position bigger or equal to 0? If the character is the very first.
Aha. Well, okay. Let's try it out. There's an indexing. That doesn't split it. Well, it depends if you want to split on the left or the right. Let's see. Oops. Right. So you're saying we should do this? Thanks. Yeah, good point. So there was a mistake with the indexing. So the position of equal to 0 is actually valid. So I guess if string doesn't find the character, it actually returns -1. Let's try this out. Okay. So now, okay, h is at the position 0. And now let's try x. Yeah. So okay, so if a character doesn't show up, then string.find returns -1, and then we jump into the else statement correctly. Good, good catch. So here's the formal syntax of function definitions. As I said, you use this special word def to define. Then you have an arbitrary function name that you can come up with. And then you have the number of arguments. So the interesting part is that you can have arguments that are mandatory, so that you have that the user has to provide. And then you can also add default variables where you specify what the value should be if the user does not specify these arguments. And then the first line after the function name is the so-called doc string, and I will explain this to you what this is in a second. This allows you to document your function. Then you have the block of statements that should be executed, and then finally the return statement. So talking about these arguments, there are actually multiple ways on how you can call functions in Python. So the first way is that you just provide the values for each argument in that function. So you say function name 1.0, x and I. And what Python will then do, it will say, okay, so the first argument, arg1, should take the value 1.0, arg2 should take the value x, and arg3 should take the value I. So an equivalent way of writing this would be function name and explicitly stating the name of the command line argument. So arg1 equals, arg2 equals, and arg2, well, and arg3, sorry, should this be, equals, right? But the interesting thing is, once you've stated these, you can actually change the order. Because once you've provided the names, Python can always figure out that arg1 here should be, you want to put, the placeholder arg1 should take the value 1. Right? If you state it here or at the end, doesn't matter. Python will always match it to the arg1 here, to the same name. So then default arguments can be left out. So for instance here, arg2 and arg3 are default. So I don't actually need to provide arg2. And I can, for instance, just provide 1.0 and change the value for arg3. And then what else is important? So when you have these positional arguments, so positional arguments are the ones where you don't explicitly state the name of the argument. They always have to be at the beginning when you call a function. Right? So, and the reason is otherwise Python can't figure out in which order these positions. Python doesn't know here how it should assign, to which argument it should assign this value. That's why they always have to be at the beginning. So one thing that's really often useful in practice is that you want to return multiple values in a function. So let's say you have a function coordinates that returns the x and y components, and you want to return both the x and the y values. In general, Python only allows you to return one value. But what you do is you just pack all the components that you want to have returned in a tuple and return that tuple instead. Right? And so what I do is I write return xy, and that's just I could have added also the normal round brackets here. But essentially what I'm doing is I return one tuple with two components, one containing the value x and one containing the value y. But it reads really nicely, right? It looks, if you don't know about tuples, it looks like I'm actually returning multiple things. So now I can call that function xy equals coordinates, and then I can use the indexing notation to get the first component out, x equals xy0, right? And the y component, y equals xy1, because I know this xy is a true tuple. But we can do this more elegantly by using this short notation. We just write x comma y equals coordinates. Right? And so what this here on the left here, again, this is a tuple implicitly, and I create two new variables, x and y, and Python automatically assigns x the value of the first return value of coordinates and y the value of the second return component of coordinates. So these two here are equivalent. But so this is what we call the Pythonic style. So often when you write something in C, you would often end up with these kind of indexing notation and looping over indices and so on and so forth. And in Python, if you write elegant code, you often end up with really readable code. So like here, return xy, and then xy equals coordinates, right? It looks much, much nicer than this messy indexing notation. So here's a really important point. As I mentioned before, everything in Python is documented, and you can use this pydoc function to extract documentation. So that means it's also really important that when you write your own functions, that you add documentation. Right? So imagine you're writing a library and you want to make sure that other people use it. You need to make sure that this library is documented well. And Python makes it really easy for you to write documentation. You should absolutely do it. The way you do it is after you define the function, the first line afterwards, if that line is a string, it is automatically interpreted as the documentation. So in this case, I have kind of a positive sign function here. And so immediately after the definition, I add a string. And so, I mean, this is just a string. I don't actually use it. I don't assign a variable name to it or something like that. I just have a string, a multi-line string. That's why I have the triple quotes. You could also just have a single line string. It doesn't matter. And so in here, I specify what that function does. Right? So it calculates, blah, blah, blah. And then the first line should be kind of a concise summary of what the function does. And then one typically has a new line, and then afterwards one can have a more detailed description if the function is complex. And if you want to have some guidelines on how to write good doc strings, more complex doc strings, there's the Google style for writing doc strings that you can look up. So now let's see how this works, right? So if I execute this, and then I'm in a IPython in a Jupyter notebook, so I can write this pos_sign question mark, and it should bring up the documentation of my function. And indeed, if you look here in the bottom, right, you can now see the signature, and down here's the doc string, and this is exactly the text that I've created. So here it's boring, but imagine I had written this file 2 years ago and I had no idea what it does anymore. But then it would be really useful to look up what it does. Good. So we now have variables, we have control statements, we have functions. The next thing is classes. And so a class is essentially a collection of variables and functions together. So imagine you wanted to write a class for a car, right? So a car has certain variables, right? It has maybe horsepowers, but it also has certain functions. You can start a car, you can stop a car, you can crash a car, and so on. And so it makes sense to kind of wrap all this functionality together in one class. And that's how you would do it in Python. You use the class keyword to indicate that you're starting a new class, then the class name, and then you actually use, you inherit. So this is kind of the inheritance of Python. And everything needs to be inherited from something. So in here, I inherit from an object. And the object is the most general object that Python has. So by default, you can always just use brackets object here. And then we use colon. And of course, we use our indentation notation here to indicate what should be part of that class. Then same thing as functions. The first line is a doc string that this explains what the class does. And then you just start implementing your functions that your car should be able to do. So there's one special function. It's called the init function, and it has these underscores, init underscores. And that's the function that's called when you initialize a new car, instantiate a new car, when you create a new car. So this is kind of a magic function that is called when you create a new car. And so take a remark here that this function takes 3 values: self, year, and fuel. And yeah, this is kind of important. I explained this to you in a second. But essentially, the car should have a year when it was produced, and I also want to store the fuel type that it takes, right? Maybe electric, maybe yeah. And then we have a start function, and again this takes a self variable, and so the self variable that always it is a self-reference to the object itself. And so the reason why I have this is because then inside that function I can write self.fuel, and I get the value of the car's fuel. And so here I can check if it's electric, and so if it's electric then it makes a nice zzz sound, and otherwise it's really loud. And then you can accelerate that car, and essentially what you do is you pass in a new speed value, and so I then use the self-reference, self.speed, to update that speed value. Okay, let's see how that works. Okay, I've just explained this. Let's see how it works. So let's create a new car. All right, my car equals car, so that's the class name, and then I can provide the attributes of the car. So I say year equals 2007 and fuel equals benzene. Let's see if that works. Yeah. And so by doing that, right, these variable names here, they match exactly to the definition of my init function. Right? Here the init function, it has the self, and I explain this later, but other than the self, it takes the year and the fuel. It was exactly also what I provided here, the year and the fuel. And so now we've got our car, so now we can do stuff with it. So we can start it. Oops, I didn't have my car. Aha. Okay, sorry. Let's try it again. I start my car, and now I can start. Now I can call the functions of in my car. So I can start it, and then I can accelerate and set the new speed. And we can also, so this is calling functions on that class, but I can also access the variables that were part of that class. So I can ask mycar.year to get the year, or I can ask mycar.fuel, and then I get the fuel of that car. So what was not quite clear is this role of the self variable. Remember when I defined the class, all the functions had started with self. Maybe I just show this again. So every single function here in it started to accelerate. The first argument was always this magical self, and self here and self here. So why do we have this self? So the first argument in a class function is always a reference to the object itself. Okay? And it's used, so what that means is when you call mycar.start, you could have also written car, so the class name .start, with self equals mycar. Right? So this notation here essentially just automatically passes this object here as the first argument of the start function. And so when I used self here in my class definition here, the name here was actually arbitrary. You can call it differently. The only important thing is that the first argument of a class function is magical and will automatically be filled by Python with the object itself. And so why do we need it? So it's needed because inside the function, we often want to query attributes about the object itself. So for instance, in my start function, what I want to do is I want to print out the sound of that specific car, right? And so every car might be different. So this is not a class attribute, right? So there's one car that is electric, the other one is benzene, and so on and so forth. And that's why I do print self.sound. So it's the specific sound of that car. Yeah. So this self is often a bit complicated when you start with. Is it clear? Do you want me to explain it again? It's maybe best to play around with this a little bit and get used to it. So then there's some magic functions that you have in magic class methods that you can implement in Python. And so the init function was already the first magic class method, but there's more. So imagine, at the moment, if you take our car and we just call the print function, you get this quite ugly output that is not really meaningful. So what if we wanted to customize this information? And this is exactly, for these type of customizations, we can use magic methods for. And essentially, these are function definitions in your class that are called when you perform certain operations on your object. For instance, if you print it. So here's a mapping between the functions that you can call, and so the operations that you can do on your object, and the magic function that is being called when you perform this operation. So for instance, when you take a class object and you convert it explicitly into a string, so the print function does that, right? So the print function takes the object, converts it into a string, and then prints it out. What that does is it actually tries to call a.__string__, right? So coming back to the example above, if we wanted to change how the printed version of an object does, we would need to implement this __string__. So then, if you wanted to allow your class to be able to be multiplied together, so if you want to be able to write A star B, then you need to implement here's actually underscores, you don't see that here, __mul__, and so on and so forth. You can implement support for addition, equality, and even calling the function, just calling that class, almost like if it was a function. And there's many more, so you can look at the reference here. But now let's go back to our car example, and let's say we wanted to make the output nicer when we print the car. So now we know how to do that, right? I need to implement this magic string function here, _string_, and it doesn't take any arguments apart from a reference to itself. And so this function now returns the string version of that object. And so what I do is I just write this is a car from placeholder driving on placeholder at speed placeholder. And then in the format, why is this not visible? Yeah. Right, in the placeholders, I actually specify self.year. This is my first placeholder, self.fuel, and then self.myspeed. It's not rendered quickly. So now, if I try this again and I say my car equals, if I create a new car and then I explicitly do the string conversion or a print, it will be the same thing, then you get a much, much nicer representation of the car. I want to show you another example on how these magic functions can be used. Imagine you're faced with, imagine you have a function f that takes in x and y values and some additional attributes, a, b, and c. And it just does some simple calculations based on that. So this is normally, I have a grid, and on each an xy grid, and I want to call that function on every grid point. And that is parameterized with the values a, b, and c. And so the idea is now that we send this function here, f here, into another function called grid values. And what that function grid values does, it takes in that function, and then it takes in a number of x coordinates and y coordinates, and a file where the result should be written out to. But essentially what's going on here is that I loop over all the x coordinates, I loop over all the y coordinates, then I want to call that function at these coordinates, get the value out, and write it into a file. Now the problem is this grid values is defined, it's not written by you, it's written by someone else. And the way that person has written it is that this function f only takes in the x and y component, while our implementation takes in x, y, a, b, and c. So how can we make this now compatible, such that we can send in our f here into the grid values? So one idea, right? So the problem is that the arguments don't match. Here, so we have 5 arguments. Down here, we only have 2 arguments when we call it, and that is fixed. But we can, of course, change our implementation of the f. So one idea would be that we use global parameters. And so what you can do is you write global ABC to make these kind of Python global. Then you say def fxy. So now I only need two parameters here. And then I can just return a plus bx plus blah, 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 blah. And a, b, and c will now just be part of the global parameters. And so down here, I can set the values of the parameters and just pass it into grid values, because now my f only takes the 2 components. Okay, you might say that's maybe okay, but global variables are, in almost all cases, not a good idea to use. So we need to find a better solution. So here's the second one. Of course, we could start using default parameters. Right? We could change our function f such that it takes x and y, and then a, b, and c, and we just set the default values for a, b, and c. Because then, when you pass it into grid values, and grid values only calls it on x and y, it will implicitly use the default values for a, b, and c. And so that's good, but what if you want to use different values sometimes for a, b, and c? Right? So you have to set, here you set the default values once, and then you can't change them anymore. So it's also not ideal. So of course the solution is to make a class and to implement a magic function. And the magic function that we implement is the call operator, because that will make the class object behave just like a normal function. Okay? So let's see how that works. So the idea is the following. We make a new class, f, and this is now a capital F. And the initializer of that function takes in the values of a, b, and c that I want to use. Right? So, and I use some default values here, but you can just use your own ones. And then I store these values a, b, and c as part of the as class variables in that of that object. And so now I also implement this magic function call. And this is always going to be used whenever I use an object of f and try to use it like a function. And of course, my call function now only uses x and y, these 2 parameters. And then what do I return? I return self.i, so I get the a value from the self reference, self.b times x plus self times c times y squared. Right? So now how do I use that? Well, the first thing is that I instantiate a new value of f, so this is my class name, right? I set the values that I want to have for a, b, and c. Then I get a class object out, f, so this is really a class object, but I can use it just like if it was a function. So I can write f bracket x equals y equals 0.5, and I get a value out. And what's happening is that actually this call function is called. I think that's all I wanted to. Yeah, I don't think, I don't think I will talk about subclasses. But so there's I think 5 more slides on subclasses if you're interested in that. But are there any questions? No? So there will be now 2 weeks on assignments on Python. So we will this week will be kind of basic Python, and then next week we will do a bit more advanced. Okay, have a nice week.